Minecraft is an enormous and expansive game built on surprisingly simple mechanics, but with the lack of tutorials, it can be confusing for many newcomers. Follow me, William Strife, as I cover the basics to the advanced of crafting, surviving, and building. Welcome to the Minecraft Guide. In the previous episode of the Minecraft Guide, a multitude of craftable items related to redstone were covered. However, the only things explained were their rudimentary purposes and how to make them. In this episode, Redstone Mechanics, the intricacies of how redstone works and the way redstone items interact with each other is the subject of interest. If you don't understand how an item is made, what its purpose is, or how it works, then check out the previous video. Now, the best place to start when it comes to redstone mechanics is the very glowing dust of the same name. Redstone is the basis for an entire complex part of Minecraft, and the dust not only serves as the basic building block for many crafting recipes, but it is also the basic form of wiring. This wiring can be placed by right-clicking with a bit of dust, and it will automatically connect to itself if nothing is in the way. Additionally, it will even step up a single block to properly connect, allowing for vertical movement of redstone signals, albeit in an awkward fashion. When powered, redstone wiring will glow and emit a particle effect. Power does not travel through the wire indefinitely though. Redstone signals have an attenuation or signal drop-off limited to 15 blocks. This means the signal will cease to be at block 16, but this problem can be circumvented by boosting the signal with a redstone repeater. With basic wiring out of the way, the next thing to cover is how to invert a signal or turn it off. Inverting redstone signals is a feature exclusive to redstone torches, and deactivating them is also tied to how you can power almost any block in the game. When a redstone torch is placed on top of a block or attached to the side of it, it is affected by whether or not the block is receiving power. If the block is unpowered, the torch stays on like normal. However, if the block is charged, it inverts the torch attached to it, or turns it off. And there are multiple ways of powering a block. Many things in Minecraft that emit or carry a redstone signal can also charge blocks as well. First is redstone wire, which can be fed into a block, so long as there's nothing else for the wire to connect to. However, it will also charge the block it's sitting on. Second are triggers like buttons, levers, tripwire hooks, or pressure plates, which directly power the block they are attached to. Third is the trapped chest, which, when opened, will directly power the block it sits on. And the fourth and final way a block can be charged is with redstone torches, which will only charge blocks directly above them. This also ties into the most efficient way to move redstone signals vertically, up and down, and is much more space efficient than stepping wires upstairs. The way this is done is simple. Blocks and redstone torches are placed on top of each other in an alternating pattern. Block, torch, block, torch, block, torch. Unlike levers, buttons, and pressure plates, which directly power the block they're attached to, torches can only charge the block directly above them. This means a column of blocks and torches basically creates a big inversion chain. When the lowest block or torch receives a signal, it shuts off. The block above is no longer charged, so the next torch turns on and charges the block above it, turning the next torch off, etc. Moving signals down, however, is a bit more complex. Since torches only power blocks above them, a single bit of redstone dust is required to pull power downward to charge a lower block. This is done by placing a torch on the side of a block, then placing another block 2 spaces down, putting redstone dust on top of it, and another redstone torch on the side. Because the redstone dust draws power from any adjacent source, it transfers the signal into the block it sits on, which inverts the lower torch. It's a little bit more complicated, but still is the most efficient method of moving a redstone signal directly downwards. The next thing that's crucial for creating certain types of automated systems and constructs is how to make a flashing redstone signal, also known as a clock or timer. Creating a timer is a very simple affair which only requires a comparator, a repeater, 7 bits of redstone dust, and a power source. The timer is constructed by first placing the comparator and the repeater corner to corner and facing each other. At least 2 bits of redstone wire need to come out the back of the comparator and attach to a power source. Meanwhile, 3 other redstone are used to connect the front end of the comparator to the back side of the repeater, creating a loop. The final bit of redstone is used to branch off where the loop begins and send the flashing signal to whatever requires a pulse. Something of note, though, is a unique problem with inverting or turning off torches. If redstone torches are flashed on and off too quickly, they will burn out and create the same sound that's made when water hits lava. To keep this from happening, the repeater simply needs to be set to the first level of delay. It slows the flashing down, but ensures that no torches will ever burn out and lose time. The final basic redstone mechanic is more of a culmination of things covered thus far, and how they specifically pertain to trapped chests. A trapped chest will only power a block immediately below it, or the block it's sitting on. This makes it easy to hide the trigger for a trapped chest by using either an inverted torch or a repeater drawing power from the powered block. The signal can then be used to do anything from moving a piston to activating a dropper or dispenser, lighting TNT, or even activating an iron door. On the note of iron doors though, there's a very efficient way to use them, by utilizing a basic redstone setup. Iron doors are great for multiple reasons, the most important of them being that they are far more durable than wooden doors, and zombies won't make a racket by knocking on them at all hours. However, they cannot be opened by hand, instead requiring redstone power from a button, lever, or pressure plate. The problem, though, is double doors are generally better than a single door, and while opening one iron door is easy, getting two to open in sync and from one button requires some extra thought. Getting a set of iron doors to work well is surprisingly simple, though. It requires one button, two pressure plates, two repeaters, and 10 bits of redstone dust. The pressure plates go on the inside of the doors, while the button goes on the outside. To get both doors to open from the outside by pressing the button, use 6 pieces of redstone dust to connect the bottom blocks next to the doors. When the button is pushed to open one door, it also powers the wire, and thus the block on the other side, which will open the other door. On the inside, place the repeaters to the sides of the pressure plates and facing the wall. Then place 4 redstone in a line behind it all to connect everything. This allows both doors to open even if only one pressure plate is activated. Also, because this is an extremely basic and useful application of redstone, it's a great place to begin learning how to manipulate the magical dust. Fully understanding why this design for double iron doors works will help set anyone on the road to true mastery and manipulation of redstone. While there's more to redstone mechanics, everything covered here is more than enough to have a sufficient understanding of the magic dust and how it functions. If you're hungry for more redstone-related building though, check out a few extra, less formal guides over a special piston door and an item pipe. If that's not your cup of tea though, breathe a sigh of relief. Then, strap on your helmet for a ride. In the next part of the Minecraft guide, rail systems are the subject of interest. Until next time, I'm William Strife of the Yogscast, and a Minecraft expert. I'll see you later.